Jake, you could actually see if you can get this room booked perfectly.
It's
bigger and it's closer to us. These pieces of the divider, that's a very, very popular space.
It has as many steps though, man.
With you know, the REVIT user group folder, is that on? Where all the where this you save all the recordings, isn't it? You know your
I would say,
yeah.
when you
Yeah. You know where that is?
I've
I've got a link on my
There's
desktop.
like 2 places.
here's my favourites here. Which is
Where? Yeah.
click favorite. Oh God! Double click on one. Wait. You're stressing me out here.
Sorry.
Yeah, it's the nursery. Our nursery.
That one? Yeah.
Yeah.
And back up.
And go back up. Go in. Yeah, I think it's
Working.
yeah. Yeah, that's in there. I think that's it. Structural. That's not what it is.
Take it back. Is it one or?
No, Chrome BIM product. Is it there? Yeah, in there.
And
That's it.
And 27.
Arrow 27.
Yep.
Wow.
Sorry. I actually created a project prepared this time. So I'll show you. It's just a basic pretty box with some ceiling in it and 2 levels. And I was just trying what I was going to explain last week. So just got a box with the building envelope. I placed the air unit on the roof, some grills on that, as you can see they're upside down. That is.
Does need my floor plan right now?
No, I placed it on the RCP. And VOVs in there. So if I go to the ground floor, basically when you in a ground floor plan you clean your ceiling, and more often we have, since we have tiled ceilings that we've got snap our grills to, so that's where the RCP is in handy. So when you create a view, you've got an RCP reflected ceiling plan view. So when I do create a ceiling plan view, I've got a working and a plot view. Basically, the plot view only has the RCP on it with nothing else on. And that reason is because in our documented view, overlay the RCP on top of the floor plan. So they're the 2 separate views. And we the reason that for is the hidden lines are displayed correctly as what current standard within our office or industry standard in Australia. This is the end that you can do.
How do you place your grills when
can't see the grid.
That's when you have your working view. So you're having on your your ductwork or your grills or the
So what sort of, so actually is a true RCP?
That's a true RCP. So when you're in your working view, when you're modelling, in the working RCP view, your hidden ones will be displayed incorrectly.
It'll be
so
wrong.
You've got to keep that in mind. So you usually just have the RCP working ceiling plan just for coordination with lighting, and you just do all your grill locations in that view, and then all your ductwork modelling you're doing your ground floor.
Right. So, yeah. Once you've got those things in the right place, you go to your ground floor drawings. Everything views right. Actually, modelling
That's
it.
right.
I can understand.
So our MEP item systems are located under that systems tab. So you've got your HVAC, which is ductwork, duct fittings, air grills. Then you've got a mechanical sub tab. Then you've got your plumbing, electrical. So I went through ductwork last week. So if we were to draw a duct on this plan, you know, first good practice is to get a feel for the project and what ceiling heights we're working at, and often whatnot. This default to a coordination. Coordination. Excellent ceiling. Okay, that's linked in from the file. Basically, when you usually get a REVIT model from the architect, they have ceilings in there that are offset from a particular ground floor, or a particular level. You can see here that there's the ceiling at 2.4 and 2.7. So more or less you have variable ceiling height. A lot of the time in bathrooms and that you have a ceiling height of 2.4, and then in the working space it's anything 2.7, 3 metre or whatever. Just create a reference plane and name it, you know, ground floor ceiling 2.7, and you name it to, I think, name it to be able to host a grill on it. Do that because the ceiling is deleted or stayed and then create a new one and at a different height, all ceilings will lose their host. So having the reference plane in our model, that ceiling gets deleted and or changes height, or gets deleted and changes height. We can move that reference plane up to hit that change. So you constantly monitor a model to see what changes there are. And I just, for instance, I've created a filter the different ceiling heights, which is in a way when you're working just in plan view, you don't have to cut a section to know what ceiling height those should be at. So I went last week, just based it up of that filter, and you just apply a colour to ceiling pattern. When the air terminal, you obviously select the right size to whatever the ceiling grid is or what the engineer specifies. Here, some options here. It depends on the family as well, because sometimes you have just a air that it just hasn't set from. This is hosted, so you can place it, or it's face-based, I should say. So you can place it on a wall, place it on a face. So you can attach to certain elements, and then you can also work plane, which is what I use. So you can then you can name on in the model, or you can go to a named plane, which is what we've created here. Those two planes that were in section. I'll choose the 2.7, and that will automatically be snapped to that reference plane. So then start placing your air terminals, and obviously when you do with the ceiling grid, you line it up. Appropriate tiles. It's good to check in section after you place one grill that they're not facing the wrong direction. With space families, they can flip over. So as you can see, it's facing the wrong direction. So you just use this toggle here for flip work plane. A lot of families have this. It just helps you get the right rotation for that grill, and then you either just start copying grill around to the appropriate line. Some tips, just like if you want to rotate, there's a spigot off the side here. That's flexible ductwork connected to a rigid duct. You need a spar just to rotate the grill.
You look at and just at space bar.
Yeah, that's right. Yeah. Which is very handy. That also do that on you can that flip toggle you can do in plan view as well. This is the section displays that's in the wrong direction. I've played two VAVs here, so pretty low in the template are families, common families that you'd use. You kind of, it's a long naming convention, but you kind of have to get used to what filter out all these prefixes here and what you need. So they all mechanical equipment. So I basically went down to here and grabbed one, and then a lot of equipment is just hosted on ground on a level. It's not like a grill space based or anything like that. Because you equipment like your air handling units are sitting on the floor, your pumps are sitting on the floor, but for the AVs, yeah, they're offset from the ground. They're within a ceiling space. So when you place a piece of mechanical equipment in the ceiling space, you have an offset here. Like we have an offset bow from a level. So my ceiling's 2.7. So if I do it at 3.3 and place it in here, so it's always good to check what height. So is there that's the height in the ceiling space. Obviously, have other services in, so you have to coordinate with them. Hydraulic structures will have beams and whatnot.
Isn't that normally go to the other side of the slab? Against the slab? That VAV box?
Yeah. It'll be under the slab. Yeah. I haven't drawn any. I should have extended that slab out.
So it'd be supported brackets off.
That's right. Yeah. It'll be supported above.
What's the equipment stands for?
It's very air volume. Like it's like it modulates the volume.
Okay.
It's got a thermostat attached to it. Like here in the office, you've got a prim zone where you've got a thermostat near the window, and it modulates how much quiet air.
It's a valve.
It's like a valve, yeah.
Or it's an AC unit, isn't it? So
it's not an AC unit, no. It has no coils in it or anything like that.
It leaves areas that
it might have a heating element in it, but no. Once you had a heat element in it, but they made them redundant because I think they're electric and they don't usually use electric heatings anymore. They usually water, but yeah. I mean, airside mechanical components. I mean, a air handling unit has a return outside air, supply air. VA has, for instance, the VAV has a supply air. It has an outside air component, or it can regulate air space back through the and then it's got your says but that's that's the return out from the space, and that's the supply which is ducted. So when you have a family, it gives you all these symbols. So across is basically supply. You have it. These are connectors, MEP connectors, and it works. So you've got a system, so it's supply air, and then it tells you what direction it's going in, and that's saying in. So you envisage air going in through this mechanical equipment, and you look at there's an out, so supply air out, so that direction goes out. So I should just explain what I'm doing there. Select the piece of equipment, right click and go draw duct from that connection, and immediately it will inherit the the offset, and it'll pick up the system as well. Like if I select the system now, it'll say
and the size,
and the size. I don't know where, there's so if I click there and go draw duct. So that's if I go into data view, inconsistent. So when a family was set up, those connectors, I'll just show you. So this is the VAV, and that connector element, so you can see it there, and you've got parameters under here of what it is. So they've created the family, they've said this flogging is out, so that's going out. System classifications. These system classifications, you've got supply, return air, exhaust air, other air, fitting, global. They're set up by pre-set up by REVIT, so you can't. I don't think you can change them. I might be wrong. I think they're built in, so you can't your own. Assign pressure drops and maximum flow values and the things. Want to go too far in stack, that will be another step. You can change to a round connector, so they're round and oval, and obviously your size. You've also got connectors, which John will probably go on about later down the track. And so you can connectors, electrical connectors, and then you've got piping connectors. Those connectors up there. So electrical connector, duct connector, pipe connector, full tray connector, and a conduit connector.
Yeah, it's just after all those past job it was that maybe require to connect electrical cables or conduit through a connector.
Yeah.
That needed for electrical.
No.
The green pipe that you got there, why is it started at the middle of the? Why is it like
So straight if you see better.
This
start at the edge.
Yeah, right at the edge.
Yeah, well, that's the way the family was set up. I don't know why that the connector resides within that
Oh, okay.
within that family.
Should
Inside
finality be to the end, like the others, or not?
Yeah, probably should be hosted on that face. I don't know why it would be doing that. Yeah, sure. Yeah. So you want to draw. Sorry.
How many terminals
Yeah.
by one VAV?
Oh, that depends. Depends on that. So, and how many, what that B is serving, what area it's serving, and obviously the airflow and how it's split up. Oh yeah,
Variable.
yeah. Good. So you can go draw duct. And so for instance, that's serving the perimeter zone. That's in a square band. But that you know, square band and T. But I can just manually change that and change it to a radius band. So all these grills here are facing the wrong direction. The spigots should be facing towards the duct, so I can just space bar them. I'm going to try and remove this. Once you create a system, you go, when you system, you have to have a piece of equipment and a grill or air terminal to create a system, a closed system. In hand, the system you any grill, doesn't really matter, and this is this mech supply air. Now that system type is predefined by the template which you can create. And it's under a family type. So if I want to duct systems, so duct is here. These were set up by I think Ryan would have set that up because he generated this template. Basic ductwork systems. You might have other things like pre-conditioned air or something like that. It's just a logical name given to a piece of ductwork. And under here, so that's ME supply air. If I go to type properties, it's got a material associated to it that gives that blue color. And that you can abbreviation here. You can type in anything you want. This is for if you're tagging a duct and you can add that into the tag. So it'll give you tag the duct with a size, and you might have a prefix or a suffix of supply air. So if someone knows that it's supply air, if it's a black and white drawing, for instance, or just a bit more versatility. Classification there is that native system type because it's supply air, because you got your real raw system classification, supply air, return air, outside air, and exhaust air and whatnot. So that's the system type air that you can see in this duct system family.
And yes, that prefix.
SA3 is just a generated number that references it, but you can type it in, say, like ground or perimeter zone, for instance, something logical. You can tick that in the system browser. You can drill to that system, and we'll bring those grills onto that same system ground perimeter zone. Then you select the parent of those, so-called parent of those grills is the VAD, which is supplying those grills. So if you select equipment up here, something. Why isn't it working? Not working. Awkward.
Should be in this one.
Or maybe all belong to another system.
Should maybe it generated it. Oh, here we go.
Under return.
Maybe I should. It's saying because that's part of another system, so it's maybe I should. These will fall under the SA2. A1. Sorry. Yeah. Anyone want to chime in to see what I've done wrong? That's fine.
You realise the most.
I would just keep plugging.
This is when it's frustrating. The problem.
No, I think it's because I couldn't.
Some bit being a detective.
There would do a match property. Does it match?
No, it should be right. That's the system. It's correct. It's saying that within the system, it's put on a box around what's incorporated in the system. So that BA and that is for players users. Maybe I should change that to yeah, I'll just rename that. Okay. There we go. We generate that system. Now we can just continually connect the flex duct into those into this duct. So it's very hard to get a flexible duct up and running. Some of the systems you've got a tab here, flexible duct. It's same as Ductwork, except it's cylindrical, so you just got to set an offset value. You have a pattern, so there's various patterns here that you can use to display a flexible duct.
What's the kind of standard?
I think it's the iron. Yeah, well, look, there is a legend. Now, where's the flexible duct? It's so I'll just know what that. I don't know what pattern that is. It must have been 1, 2. So I select that MEP connector on the grill. So you'll see it snap to it with that icon. You can't really see like a circle that crosses through it. And then on the duct on the edge here, and it automatically put a fitting in, which is very ugly. I don't know why these aren't defaulted to taps. Yeah, I don't know what. Like, always know the offset height of your duct that you're connecting to. So 3.2. So right click and go. So you get to flexible duct, and then you can type in the offset value of 3.2, and then select the duct, and that will put that flex duct in, and that's the symbology as per the legend. So if we do that for all these grills,
I can't remember seeing you get the height of the duct. Is that because you've got the VAV?
Yeah, it just inherits the set from the VA from that connector, that MEP ductwork connector here. Just there.
Okay. So when you right click,
Yeah.
When you right click the air terminal, even though it knows where it is in space, you don't know where it's going, because that main duct could be anywhere. I get it.
That's right. So this connector that's coming off the tool is, if I delete that and I go right click and go draw flex duct, it's this 3.25 mil above the floor. I know that
it's higher.
It's higher.
Yeah.
So when I connected it in before, it was connecting underneath the duct.
Yeah.
Which is not what we do. So
How does it know where what level?
That's
why we type in 3.2. I selected that duct before, this duct, and height, offset height.
Okay.
So that offset height for that duct is 3.2 to the center line of that duct. So if we type offset here 3.2 for the flex duct, it's going to connect smack in the middle of it.
You don't draw it straight.
Actually, group. It's all right on a ceiling tile, like a ceiling with tiles in it, because you can just pop open a tile and adjust the spigot. But if you had a plasterboard ceiling, you'd usually access the spigots by an access panel, and that's where you should group spigots together. So that's a bit yeah, that's right, to minimise, because if you had a access panel every spigot, you could imagine what it would look like on the ceiling. So
Or is a issue of connecting the terminal to the duct when they ask clear.
issue when you do, for instance, into
Like if that terminal are so close to that duct.
yeah, if I draw a flex duct and I want to tap into the side here. Oh no, okay, room again. It does automatically wants to connect to the end, and that's for when you even you have a if it's sitting down and I draw a flex, install this reducer. And you're like, I don't want. It's silly. There's a fitting there. I don't want to dash that duct run.
So you will connect it right before that and just
Well,
cross, can you?
yeah. So what you do is you just draw the duct 3.2 and connect it up, then move it back down, and move it back across, and you do move vertex point. Coordinate flex duct in a MEP model because it's and beyond our
Yeah, I think when
our LOD.
coordination, you just turn it
flex duct. I mean, it's just
off.
So what does that
a rigid piece.
what does that look like in 3D with on high on high detail?
Shaded.
Oh,
Hang on.
hang
It's
on.
on coordination. Just a flexible piece of pipe. If you right click on that flex duct, you can add points. And
You can actually, if there's a big piece of equipment there.
Anything around
you
it.
can,
good
but
to it.
you wouldn't really coordinate it.
Generally, we will
That's
be
great.
calm to do that because we know the contractors can install around equipment because it's flexible.
Okay. In a ductwork system, you have to have a closed system. So if you have a piece of duct system with your end, it needs a cap on the end of a duct run because it doesn't know what's happening at this connector. It just assumes that it's open connection, that air's spewing in here, and it can't calculate air flows and all the nitty-gritty sort of stuff in MEP systems or mechanical systems. So you can that can fix by adding a duct fitting. Here you've got to just no, that's the you've got to read what so then here, so you can add on and then close the system off. You can
right to the end.
yeah, you get a duct. You can go in and it'll automatically put that fitting on.
It reads the size of the duct. It knows how.
That's that connector. It is the connector, the size of the connector.
So if I need to draw a new piece of duct or modify that, do I need to delete the end cap first before I can modify it?
Sorry?
If I need to extend the piece of duct.
Yeah, delete that. If you wanted to, yeah. So I'll just put that in. Now, when sizing a duct, this is the theory of how you do a mechanical system, and you should size this way, and well, this is the way that I've been taught, right or wrong. The element here, I assume structural guys have used this quite a bit.
Yeah,
It's a great tool.
Yeah.
Yeah. So you just select the piece of duct that snaps to the edge of it, and you can make that time. It puts a union family, which is just a with two connectors on each side that just basically splits the duct and keeps it joined. We do this is that when you go to automatically size the duct, it will put a transition in there. So put another split here, another split here. So the duct should show an airflow going through it. Go down to, and it doesn't.
Because it's open.
No, I closed it. That's because I remove. So they should be further up the hierarchy. No, that might work. Yeah, that's right. The other was wrong in that system. The V, the parent of these air terminals. I bet you the airflow still doesn't work. No. Hmm?
Usually work.
Yeah, I don't understand why it's not working. Is there any others?
There is a lot then.
No, we don't.
I think it's LO3 or LO4 side of things, and most of Australia only does L100s and L200s, which is just a graphical representation of ductwork and CP stuff.
This is why I need to have these sessions, because more and more are going to be asked to do this, and we'll stand to do it. And with the design, designers will be able to start citing the using the
That will definitely require a very high levels of close communication among the drafting team, because a project like this that require that sort of system levels. But if I'm have to do a job and Max on board, Emma's on board, definitely that communication has to be.
That's a bit of a recipe written down and put into the drafting plan and the execution plan. That this is the system. These are the system types. You'd actually have to plan that stuff.
Because it's easy for one person to construct it, but once the draft or even IDC is to have that communication channel broken.
Yeah.
Right. We have set up a beautiful system for someone at the other end. Just treat it like any drafting job and just draw in there without regarding to systems.
That's right. So you'd absolutely definitely have to have written down and planned and recorded what you're going to do.
By the time you know it, you just
yeah.
Usually the engineer will give you the size of the equipment and most of the limits in it. So when you do ductwork, I'll have a bit of an idea of how big it is, or what size it is. Then you do this, press this cam bit, and then it will automatically test check it for you.
Yeah.
So it's a good check as well for the engineer as well as for yourself. You may go, yeah, we want it to be way through, but there might be some way. So all of a sudden you've got a space issue, so you've got to change the ducts. Instead of being square, you might have to turn it into rectangle, but have the same size airflow through it. So as you're drawing it, all of a sudden the duct might change in the visual side of it. It might work if you don't keep the airflow all the way through, correct?
Yes, part of it for high levels of documentations or details definitely requires someone who in the trade, like for example, doing a system like that. Definitely looks skilled properly.
You have to know what you're drawing.
Yes, that's the thing.
You can't just be tracing and copying.
But maybe,
you can.
but the point nowadays is basically just drafting job to whoever's
Yeah.
available at the time.
It's a bit like, but you have to understand the load path, everything being resolved, how the force is getting down the foundation. And it's much easier. As you can see here, you have to actually understand how it works.
Mm-hmm.
Still got no
I've got no flow going through.
we're all fading now.
Once you get the flow parameters, then you can tag it. Is that right?
Tag it, but then the duct sizes usually will go lower near the equipment, and then as it gets closer to each of the grills,
Or it automatically
it will size it.
the airflow.
Yeah, it'll get smaller and smaller and smaller. That's REVIT. So it tells you whether the piece of equipment that either the engineers asked you to put in, or the equipment that you've just put in, if it's big enough or not big enough for that room or for that area. And the engineer, you can go back to the engineer and say, look, this is not going to work. You know.
You can test the design.
Yeah.
I'll show you.
Maybe you should pick up again next week. Look.
Yeah, I will.
Part three.
I could go through. Or...
Because there's also the spaces in there. We're in a space now, and these two guys here.
And this will change the situation too when you change the room off and you open it up. All of the
You don't have to actually input some information like the room size.
No. Put an arrow in.
The engineer calculates all that.
Yeah,
They'll be picking up the flow here. I've
Just have it
got
attached
a.
to it. Information.
It should have a flow in the flex
Or
duct at least.
is there a switch in the VAV unit? You can switch them on first.
It's working from the grill back, not the way around. Like a big area up here. I'll try a different grill.
Good.
We'll go in the flex duct now. That's not connected at the moment, but. Yeah. It's like stuck now. I don't understand that.
That was who this room was booked.
Yeah. Okay. Yeah.
So
Who determines the flow?
You.
So you have to know that.
Yeah. Yeah. The engineer will tell you the flow that goes to the room, and they either a number of drills in the flow, or they give you a total flow for the room, and then you the flow and the one in the room. Understand why that's not working.
you can have a look at that and rip that.
Because it's working on that flex duct now. That's saying 300. One's showing 0. About 60 litres in there. I'll speak to Ryan. All right.
Thanks.
Sorry about that. I don't want to head
It's good though. Generate a lot of dialogue.
Planner system is quite a unique thing because everything got to be independent, got to be unique, and
So we connected and they've got to have the hierarchy right.
yeah,
That's how